Hi, today's topic is the law of sines, and I missed the video yesterday on March 26th, so you can use March 27th as today's date. This is the note packet that you'll need to go through the notes with me. So the topic law of sines, when we've done any trig ratios up to this point, we said we could only perform any of those trig functions on right triangles. What we're going to do is deviate from that, and the law of sines can be used to find a missing side or a missing angle on triangles that are not right triangles. So this is what the law of sines looks like. It's actually a continued ratio. It's comparing the sine of A, which is an angle measure, right here in pink, and we're comparing it to the side across, which is capital A. Sometimes we do switch them, and capital A would be the angle measure and lowercase a might be the side length. But that ratio would be the same as sine of B, so the angle here in green, and we're comparing it to side B across from it. And the same ratio applies to sine of C in blue, the angle being compared to the side across. Now we don't use all three typically. When we're doing a problem, we'll only pick two of them. You can also see that the sine of A does not have to be in the numerator. It could take place in the denominator, and then the side lengths would be in the numerator. It's fine as long as you keep the like items together. So angles stay together, side lengths stay together. We have another law coming up in the next couple lessons. One of the key issues here is when would you use the law of sines? First of all, it wouldn't be a right triangle. It would just be some random triangle. But if they're providing two sides and two angles, and I know one piece of the proportion will be missing, but that would be a good indicator as to when to use the law of sines. So let's try example number 1. They're asking us to find b to the nearest tenth. B is a missing side length. We're going to start by setting up the proportion. So I'm going to start with sine of 45, and I'm going to compare it to side length of 30 because they're across from each other. And then I'm going to go to the sine of 74, and I'm going to compare it to the missing side B. You'll notice the sine values are in the numerator, and the side lengths are in the denominator. We are going to cross multiply. We're going to use the product of the means equals the product of the extremes. And to isolate B, we're going to divide both sides by the sine of 45. On the left-hand side, they'll cancel out. You can type the whole right side right into your iPad. Remember, if you want a decimal answer, you'll need to insert a decimal probably on the 30. Or you can simply take the answer it gives you, hold down the enter sign, and slide up to that equivalence, the squiggly equal sign, and it will convert it into a decimal for you. So when I do that, my side length for B, this is unrounded, and it does say to round to the nearest tenth, which is 40.8. Remember, you can pause the video at any time if you'd like to try the examples on your own. In example number 2, they're telling us that we have triangle ABC, but it's not drawn. They're also providing the measures of two angles and one of the sides. So I'm going to draw the figure first to model what they're telling me. I've used capital letters for the angle measures and then lowercase letters for my sides. So based on what they've provided, I've got an angle at A with a side across from it and an angle at B with a side across from it. So I'm going to write the ratio, sine of 68 being compared to side length B, sine of 37 compared to side length 3. And it doesn't matter which ratio comes first. We're going to cross multiply. And then to get B all alone, we'll divide both sides by sine of 37. And again, you can just put this right into your iPad in fraction form. If you want to get a decimal equivalent right away, tack a decimal onto the 3. and there it is, rounded to the nearest tenth. In example 3, now they're asking us to find a missing angle. You can use theta at D, or you can simply call it lowercase d. So we're going to set it up the same way. I'm going to start with sine of 58, and I'm going to compare it to 24. These two pieces are known. Angle D is sine of theta, or sine of D, and I'm comparing it to the side across from it, which is 28. For the most part, this is exactly the same as example 1 and 2. We're going to cross multiply. The goal here, though, is to get sine of theta alone. So we're going to divide both sides by 24. You're going to also put this left-hand side into your calculator. We do want a decimal equivalent. So I did put a decimal on the 28. This is the equivalent. Remember, when we find an angle, we need to use the inverse function. So at this point, I'm going to activate the inverse and switch theta and the decimal. And then I'll type it into my iPad. And this is the angle measure. They're not telling us how to round it, so I'm going to follow suit. They gave us 58 degrees as a whole number, so I will also round it off to 82 degrees. In example 4, they did not provide a diagram for triangle XYZ. So I'm going to draw that first and label the things that they've provided me. They're looking for the measure of angle Z. So I'll set up my proportion. I'm starting with sine of 92 being compared to side 17, and then sine of theta compared to 14. So you can see I've already cross multiplied, and then I'll divide both sides by 17. And there's the decimal equivalent for the sine of theta. Again, we're going to activate the inverse sign. We're going to switch theta and the decimal. Make sure your calculator's in degree mode. And I've rounded my angle off to the nearest whole degree to follow suit with angle Y. Now, one other type of example does exist. Sometimes the problem will ask you to solve the triangle. What they want you to do is find all the pieces that are missing. So any missing angles need to be calculated and all missing sides so that we have a complete picture. So we're going to solve triangle ABC. Again, they did not provide a diagram. So let me start with the diagram. This is the information that they've provided me. You can start anywhere in the solving process. Sometimes I look for what might be the easiest. And in this diagram, it looks like solving for theta would probably be the simplest solution. So if we know 180 degrees are in a triangle, I'm going to subtract off the two angles that I know. So angle C is 100 degrees. You can set up any type of ratio that you want. You can keep using 33 and 47. At some point, you will need to use the 100. So I decided to start there, and I'm solving for side C first. So sine of 47 is compared to 14, and then sine of 100 is compared to C. So again, we're going to cross multiply. And then to isolate C, we'll divide both sides by sine of 47. I'm going to put this whole fraction right into my calculator. And I'll include a decimal somewhere in there so that it returns a decimal equivalent. I'm rounding it to the nearest tenth because it's not a whole number, even though side B was provided as a whole value. Now I've got the one missing angle and I have one missing side. There is still side A to calculate. So I'll do that. I'm going to stick with sine of 47 is to 14. And now I'm going to use sine of 33 is to A. So same thing here. We're going to cross multiply. We're going to divide both sides by sine of 47. And I don't think I showed that step. And then ultimately, there's my decimal equivalent. We're going to skip example number 6 just for the sake of the video being too long. So we'll do this when we get back to class. It'll be a nice review. This is homework number 104. It does say the law of sines at the top. As you go through your homework, please feel free to contact me if you have any questions. You can email, you can text me or call me on my cell, or you can call me at home. Have a great day.